2019, Paper 2, Question 9. Part A, find the distance from S to G. As we can see in the above triangle, it's a non-right angle triangle. So we're going to use sine rule or cosine rule. Here we're going to use cosine rule. With cosine rule, remember lowercase letters are sides, uppercase letters are angles. If I start with side A, I must end with angle A. Angles and corresponding sides are found opposite each other. So the side SG, which we're looking for here, is opposite the angle 68. So filling into the formula and working it down, you get SG is 54.4 meters. Part B, find the angle HSG. S is the center number here, so it's this angle up here that they're looking for. Right angle triangle, so sine or cosine rule. You can use both here. I'm going to use sine rule just because. I'm just going to call the angle up here the angle S. With the cosine rule, always start with the side you're looking for. S over the sine of, apologies, I'm looking for the angle S. So then I'm looking for sine of S over the side opposite, which is 30. That must be equal to sine of another angle, you know. Let's use 68 over the side opposite, 54.4. 30 is dividing, so when I come across to multiply, and finally to get S, we get the sine inverse. And we're left with an angle of 30.75 degrees. Next up, part C, find the area of the triangle SGH. Give your answer meters squared, correct to 2 decimal places. Going to use the formula, area is equal to half AB sine C. So remember to do that, A and B have to be sides, and C has to be the angle that goes in between them. I'm spoiled for choice here, but I'm just going to use 30 and 58, and my angle is 68. Alternatively, I could use 54.4 and 58, and my angle is 30.75. That would be fine as well. We get an area of 806.65 meters squared. Find the area of the triangle HSP in terms of OR, where OR is the radius of the helicopter pad. Because HS is tangential to the circle, we know using our theorems that the radius here must be at right angles. Therefore, we could refer to this as the base, and we could refer to the radius as the height. So using area is equal to half times the base times the height, filling in OR for the height and 58 for the base, we get 29 OR meters squared for the area. Show that the triangle SGH, in terms of OR, can be written as 71.2 OR meters squared. We've already found the red triangle in terms of OR, so let's find the remainder of the shape in terms of OR. So looking at the green triangle, using the exact same method, 54.4 will be our base, and OR again will be our perpendicular height. So the area of the green triangle will be 27.2 meters squared. The last part of the shape is the blue triangle, and again we can call 30 meters our base, and again the radius is our perpendicular height. That will get 15 OR meters squared. So when you add up the red triangle, the green triangle, and the blue triangle, you do indeed get 71.2 OR meters squared. So we know the area is 71.2 OR, but we've already figured out that it's 806.65 meters squared, so we just simply divide to find the value of OR. You get an answer of 11.3 meters. Part E, we have to find the height of the pole S to T. The point P lands equidistant from the line SG and SH, which means it's on the bisector of the angle between the two. Which means it chops the angle into 15.375 degrees apiece. We also know that OR is 11.3 meters. With 15.375 degrees as my angle, I name my sides opposite, adjacent, and hypotenuse. And I use SOHCAHTOA to find the length from P to S. Sine is opposite over hypotenuse. Rearranging the formula gets the distance from P to S is 42.619. Back to the drawing in the picture, I now know P to S is 42.619. With the angle of 14 degrees, I have a right angle triangle, so I can name my sides opposite, hypotenuse, and adjacent. Tan 14 is opposite over adjacent, which is TS, over 42.619. Then get a length from T to S of 10.6 meters.